Hello Pre-Calculus, this is the last video or set of videos for the semester. 5.2, Solving Right Triangles Using Trigonometry. So, I'm banking on the fact that you guys have talked a little bit about trig ratios in previous math classes. So this first example is just to kind of unearth that stuff and, recap everything trig related. So there are three main trig ratios that you guys probably worked a lot with. The sine of theta, which is abbreviated SIN. So it's basically saying we're taking this concept of a sine and applying it to an angle, okay? You've got the cosine of theta, again abbreviated COS, and then you've got the tangent of theta. Now those are three of the six trig functions that I'm going to talk about now. So the idea of trigonometry was to basically say, can I in some way relate the angles and the sides in one equation? Because when you can relate the angles and the sides, having maybe limited information is now more powerful for you. So the sine of theta represents the ratio or the fraction of the opposite side length over the hypotenuse of the right triangle. So when you think about this, everything is determined in relation to theta. So when theta is in the upper right-hand corner here, opposite theta is now this side 3. The hypotenuse is always going to be the diagonal, so it's going to be 5 right here. And there you go. The sine of theta equals 3/5. That is the value of when you take the sine of that angle. Now keep in mind that if I put theta down in this corner, then the sine would be 4/5. So it really does make a huge difference what angle we're actually talking about. Okay? So cosine. What does that trig ratio represent? Well, it's all about the adjacent side. Adjacent just means next to, divided by the hypotenuse. So the cosine, it's connected by two sides right here, okay? When you say adjacent to theta, it's sort of like, well, isn't that adjacent to theta and isn't that adjacent to theta? Technically, yes, but we're always talking legs when it's opposite and adjacent, okay? So that's the adjacent leg. This is the opposite leg. So maybe we should include that here. Yeah, so the adjacent leg in this case is 4. The hypotenuse again is 5. And like I said before, if theta were down here, then the cosine of that theta would be 3/5. All right, moving along. Tangent is just going to be the opposite leg divided by the adjacent leg. So no hypotenuse is included for tangents ratio. So if theta is here, the opposite leg would be 3. The adjacent leg would be 4. And there it is. So 4/5 is the cosine of theta, 3/4 is the tangent of theta, and then the sine of theta is 3/5. Now, these are the general 3 basic trigs that we find most use of, but when we get to upper level maths, like pre-calculus, we start to work with 3 other trig ratios, which are actually called the reciprocal identities to these 3 that you see here. So what I mean by reciprocal is that their fractions are flipped. So sine has a reciprocal ratio called cosecant. It's abbreviated CSC, cosecant of theta. And the cosecant of theta is equal to the hypotenuse divided by the opposite leg. It's just the flip of sine. So hypotenuse divided by opposite leg. So it's 5/3. And then much in the same vein, cosine has a reciprocal called secant. And that's abbreviated SEC. Hypotenuse divided by adjacent leg. And that's just going to be 5/4. And then lastly, the reciprocal of tangent is going to be called cotangent, abbreviated COT. And that's going to be the adjacent leg divided by the opposite leg. In this case, it's 4/3. All right, so this is your basic reintroduction if you haven't been introduced to it before, or I guess if you have been introduced, here's a recap of the 6 trigonometric functions that relate the sides of a right triangle, it's got to be right triangles, with the angles of those right triangles. All right, I think it's actually a good idea to stop it here and just say, here's a video for people that want to get that recap of, the trig ratios. Be on the lookout for part 2.